Hello friends, in this video we are going to show you the execution of hue, saturation and value program in Hadoop and MATLAB integrated environment. Here we are showing this entire process by considering 1000 images. There are a total of 7 steps involved in this entire process. We are going to show you the each step that how we have executed that. So as if you consider the first step, here we need to update the time in master and as well as in slave nodes. So first we'll show you that process. Go to terminal. Now we need to update the time in all master and slave nodes. But instead of doing that updation individually on all the slave nodes, we have written the script like the one which you are showing here. Now directly you take it and you can execute it on all the slave nodes at a time. Lightly through terminal we can do it. It is a script file, shell script, and give this yeah. Now it is updating the time in all the slave nodes. So why we need to do this is when we are installing that Ubuntu, there is a chance of installing that in different time zones. So now by making this execution, we can make sure that the entire time zone of all the slave nodes come to one standard time zone. So I think almost, yeah, we have completed for the slave nodes. Now we need to do it for the master node also. So just we'll go and just paste that same command whichever we have used for the all the slave nodes. Yeah, this is the command. Just you copy and paste it in the terminal. This is for the master node. Now we have completed the first step. Now second step. Now we need to start the Hadoop cluster first. Go to the terminal, start dfs.sh. Yeah, we are starting that. Yeah, now that name node got started. Yeah, all the data nodes it is doing. Yeah, secondary node also got started. It is starting, and yeah, now we are completed. Now we'll start yarn.sh. And meantime we can check in the browser that whether how many nodes got started for our cluster for storage purpose. Yeah, you can check it. There are 110 systems, but as in our previous cluster we were having 115 system, 115 slave nodes, but because of some memory issues we have removed 5 systems from our cluster. So that's why it is showing 110 nodes as slave nodes. And with this we can say that the total memory configured capacity is 27.44 TB. Okay, now we'll go to terminal and see the status. Yeah, still it is starting that node manager in some of the nodes. Yeah, it has completed. Now we'll go to browser and see whether all the nodes are ready for processing or not. I type 088. Just click on the nodes. Yeah, now we can see that all the nodes, just if you can sort them. Yeah, now you see some of the systems are from CT lab and some slaves are from DE lab and the remaining are from SC lab. Now we are having only 110 systems in the slave nodes, one master node. And now we'll see the third step. And now we have to start the MATLAB. Okay, and go to terminal. Okay, now we have taken the separate terminal for it. Like, that is optional to take the separate terminal. We have used R2016. So directly we are starting it now. MATLAB. Yeah, MATLAB got started. Now we'll see. Now we'll see step 4. Yeah, we have to upload the 1000 images. Yeah, now we'll be showing the process of just putting the original images into HDFS. So this command IFS, we are going to create one directory for it first. Coral 1k 1000. Okay, sorry, 1000. Yeah, now we'll be uploading the given images. Previously we have downloaded these 1000 images from the internet and they are in some one of the folder. Now we are copy pasting, like we are uploading those images from the local file system into HDFS. Yeah, now I think it may take some time, but we just will go to the browser and see what is the status of it now. It will show the number of images that we have uploaded so far, and the file name that we have given is Coral 1000. Yeah, and you can see it. You can, yeah, as it is copying, it is doing. You can refresh it so that it is updating the number of images that it has uploaded so far into HDFS. I think it may take around 4-5 minutes to come to upload all the images from local file system into HDFS. Okay, we'll wait for a while to complete this step. And actually we have given the replication factor as a 3 for each image. Just you can see it by clicking on that image. Yeah, it is there in 3 different systems. One is in DE Lab 160 and DE Lab 182, CT Lab 203. Of course, we are having the synonyms for it as a slave 1, slave 2, slave, some slave number for it. But here it is taking directly that actual system name. Yeah. Just will see it. Yeah, now all the images got uploaded. Now we'll see the step 5, that hue, saturation and value MapReduce program in MATLAB. And we'll open that code. Video recording, hue saturation for 1000. We'll be opening all the files which are needed for this, and we'll be putting them in order. Just okay, now just we are arranging them in some just order. It is optional to put them in order, but for our convenience, just we are putting so that easy to. Yeah, this is the actual program where this is the entire cluster setup, and here it is to make sure that we are going to execute on Hadoop cluster. Then this particular, yeah, this is to give the path of that HDFS folder, and this is the path from where that actual images are there. Now our images are there in Coral 1000. This is the path. Yeah, that is the path that you can see. That's why we have changed it to that. Then after that, now this the next statement is going to read all the files from that Coral 1000 and putting into that a data store, that is image ds. Then okay, after that we have created just one folder name to keep the result. In game we are giving it as 1000. Now the actual process starts here. This is the job 1 in our MapReduce, where it is going to convert the all 1000 files into sequence file. Okay, then this is the job 2. So the output of that sequence file is stored in output into this sequence folder, sequence ds, and okay, now we are going to show you the step 5 where it will be showing you the hue saturation value program in MapReduce with MATLAB. I'll go to MATLAB, I'll open that file, all the programs, video recording, hue saturation of Corel 1000. Yeah, there are 5 files to complete this process. That's why we are opening all files. Now just we are rearranging them just to make sure that they are in some order, and this rearrangement is optional. Okay, yeah, now first we'll just directly we'll see that main program. Yeah, here if you see the first 5 lines are to set up that entire Hadoop cluster. Here we have used Hadoop 2.7.2, and this line it is to make sure that we are going to work on Hadoop cluster. And now this one is the path where that actual that 1000 images are stored. Now we are going to get all those images paths from there to this demo folder one. And now we are first thing we are going to create a image ds by reading all the files which are there in that Corel 1000 database. Then this is the first map reduce job. To complete this job, we are using one mapper and one identity mapper and one identity reducer. The job of this identity mapper and identity reducer is to convert the 1000 images into sequence file. So, and this is the path where the result of the job one is going to be stored. That's why we have created one folder with name Corel 1000 sequence file, and we are giving it here. And in the second job we are going to perform that the actual processing of the finding out the image with maximum average hue, maximum average saturation, and maximum average value. So for that we have written one mapper here and one reducer here. And similarly, like the previous case, as we need one output folder to store this one, now we are just giving that path where the output is going to be stored. So output will change the name, output 1000. Yeah, output 1000 will give like that, and the same thing now we are going to give it here. So this output is, this folder is in HDFS. Okay, then at the end it is going to be stored in output HDFS. So now we are going to read that the result of that job 2 into max HSV. Here actually we are going to have only 3 file names. So now this last for loop is going to compare the 3 file names which is retrieved by the job 2, resulted by job 2, with the file names in the actual files, that is in the um, 1000 file names of the original data list. So now just you can see what is the code in identity mapper and reducer, and this is mapper and this is identity reducer. Just it is the process just to convert the 1000 files into a sequence file, and this is the code to retrieve the maximum hue saturation and value, and this is the reducer to find out the one with maximum average, and with the one with maximum average saturation, maximum average um, hue, and maximum value. Now we are going to execute this. You go to this one, and yeah, I'll go down, give that, run, click on add to path. Now the actual execution has started. You can see, I think finally we are going to see 2 jobs here. Here you will get 2 map reduce functionalities. So job 1 here it is to convert into sequence file, and job 2 is the actual process. You can see it here. Now we are doing that step 6, converting image in sequence file, calculating HSV. Both will be done in the entire step 6. Even in our code, the step 7 also we have written in the code, which is going to display the actual the resultant 3 images out of 10 out of 1000 images. So we'll see the processing there. Yeah, just to see, we'll go to the browser and see the status, how the nodes are working. Yeah, can check. Yeah, these are the systems that are running now, and all the systems are active. All the systems are used in the processing. Yeah, very nice. And we can see the present the time how much it has taken so far. So far it took 1 minute 18 seconds for job 1. Yeah, we'll go to MATLAB and see that there. It's almost completing job 1 now. 109 100%. Yeah, now that job 2 has started. Now it is completed map job 2 also. Now you can see the 3 images displayed by it. Yeah, so these are the 3 images out of that 1000 images. One with maximum hue, average hue, and one with maximum average brightness, and one with maximum average saturation. Now we are going to show the same process for 1 lakh images. Now we'll be just running one more program which we have written it for 1 lakh images. If you open that, yeah, first we'll clear the screen. Okay, now we'll going to open the program for 1 lakh video recording. Yes, where is that folder? Yeah, few programs, but Flickr. Yeah, but if you see here we are having only 3 files. Opening all the 3 files and just arranging them as one is the one, and mapper, and the reducer in that order. Now if you see this one here also, once again the first few steps are to set up the cluster, and this one is to make sure that we are working on cluster. Now previously we have used only one folder. Now we are giving all the folder names here. So these folder names are useful only in the last step to compare the resultant file name with the file names in this these 10 folders. Here each folder is having yeah, 10k images. So altogether it is 1 lakh images. So as we have already uploaded, we are not showing that entire process of uploading that 1 lakh images into the database into HDFS. Yeah, you can show, we can see those images which are already uploaded into that. So just the images. Yeah, these are the folders, and each folder is having 10,000 images. I think we clicked on it. It is taking some time to open. Now these are the file names of that 10,000 images. Okay. Now, now the program here is same as the previous one. So that image ds is used to read all the file names from there, from HDFS to this MATLAB variable, and here it is to store the data Yeah, because and one more thing here, actually we are not create we are doing only job 2 here. So job 1 we are made already into sequence file. Directly we are showing the execution of the job directly from the sequence file. So that's why directly we are reading the files from the sequence file and put it into variable seqds. Then just we are going to execute this by using that hue saturation mapper and hue saturation reducer. As in previous case, we need that map folder to store the data. That's why we are giving the folder name here. Just we'll change it to some other name. Output 1 lakh, and that same folder name also will give here. So this is the folder name where that this folder name is in HDFS. The result will be stored there. Okay, now once again here this is the code where in the read all max HSV finally it is going to have only 3 files, and that will be stored read from this file name sorry this for max HSV to table, and we are going to compare these 3 file names with the file names from this folder 30 to 39. So this is the code for that. Now we'll give it for execution. Click on run and let's say add to path. Now the execution has started. Initially it is going to give that cluster setup information. Yeah, that it has almost started. Here we are going to have only job 2 because we already created the sequence file separately, and we are using that sequence file here. Yeah, now it has completed. Now you can see the output of that. Yeah, one with the maximum average hue, one with the maximum average brightness, and one with the maximum average saturation. This result is for 1 lakh images. So thank you for watching this video. In our next video we are going to show you the content based image retrieval mechanism by using MapReduce model with this MATLAB and Hadoop integration, and we will be showing you the results on 1000 images, 1 lakh images, 5 lakh images, and 1 million images. Thank you.